So, can one of you give a quick summary of what we have discussed in our last session?
Oh, black.
So we have discussed string class, why it's immutable, that it cannot change the object. It's we can only change the reference to the object, but not the value itself. And the string is made of final and not allowed to extend it and destroy its immutability. And the purpose is to secure security reason and like to save the space in the heap memory.
Okay.
And another one we discussed is object class, which is the parent class of all the classes, and all the methods that it has. Inheritance, where its inheritance is the process where one class acquires the properties and methods of another class. So there is like a parent class and the child class. So the child class inherits all the properties and method of the parent class. There are like 4 types of inheritance: single, multi, hierarchical, and hybrid. Yeah, I think that's all I got.
Yeah. I think thank you for that. Sorry, I didn't get your name.
Varsha.
Thank you, Varsha. Okay. So just to add few more points, right? So yesterday we were speaking about string class, and we discussed that strings in Java are immutable. Like whenever you try to change the value of string, it will create a new object, right? And we talked about different methods a string class would contain, and we just went and tried some of them, and we talked about then we went on talking about object class, where we said it's a superclass of all classes in Java, and we looked at different methods available in Java. So if we can name some of these methods: equals, hash code, wait, notify all. So all these are some of the methods that are part of object class, which will be available across all the classes, right? And then after exploring these two classes, string and object, which are by default available in Java, we went on talking about inheritance, right? One of the object oriented principle, where we spoke that you have two classes, the parent class and child class, and your child class inherits parent class, and it is also called a superclass and subclass, and your subclass acquires the properties of your superclass, right? And we use the keyword extends to implement inheritance, right? Whenever your subclass basically extends your superclass, whatever properties of your superclass are present, be it the variables, instance variables or instance method, everything will be available to B, right? Your class B, which can use the same. And we talked about different types of inheritance that are there: single, multi-level, multiple, hierarchical, hybrid. And I think you in the slide you can see, right, how the hierarchy would look like, right? And yesterday we saw a very basic example of single inheritance, right? You have a class A, class B, and then we just saw, right, like you have a couple of methods in class A and couple of methods in class B, right? So we will now just try to extend on that, and we will dig into further concepts of inheritance, and then we will look at the other aspects of inheritance. Okay. So having said that, this is the yesterday's inheritance, whatever we use, right? So I want to take this class here as well. Okay. Now, if you see the program here, this is our class A. This is our class E, the subclass, right? Yeah. So here we have. Now we created an object of class E, and then we talked about E.C, right? Using this object, you can assign some value to this, and you can call this show method. This is something we already knew, right? But if you see, this is what inheritance is giving us, right? When your class E extends class A, because of the inheritance, you can now access the A and 𝐿𝑎 properties which are part of your parent class, right? And this is fine. This is what we saw yesterday. But instead of this E, if you see, right, E is of type of object of E, but the reference is capital E, right? Instead of E, I'll put this to A. Okay. Instead of E, I'll put this to A. Now, if you see, forget about the these errors. Yes, they'll come. Now, if you see here, still I am able to call these two methods. But I mean, this methods no, but this methods I'm able to call it because of the reference, and but I'm assigning the object to EC. Now this is a different syntax you are seeing altogether. Till now, whatever is the type we mentioned here, we were seeing the same type. But if you see here our reference is now of superclass, right? But the object we are assigning is the subclass, right? So this is possible. This is possible because of this inheritance. And now we are going to talk about polymorphism, one of the polymorphism concepts, right? Like I hope you guys remember the polymorphism discussion from our initial class, right? So what are the different types of polymorphism we have, guys? Different types of polymorphism.
Method overriding and overloading.
Method?
Overriding and overloading.
Right. Method overriding and method overloading, right? What exactly are those?
Compile runtime.
Right. Your overriding is runtime, right? And your overloading is compile time polymorphism. Okay. But what exactly are those? In what context they will we will have them? Like for example, let's take care of overloading, right? What is overloading? Like you have a method, multiple methods, all methods have same name but with a different set of arguments and return types, right? So that is something, nothing but your method overloading. Now talking about method overriding, which is basically a runtime polymorphism, it comes into picture when we talk about inheritance, right? Like say you have a show method here. Okay. And assume here also you have show method, same method. This is quite possible. Okay, I'll say here show E. show A. Okay, so that means your class E and class A, both classes have a method of same name, right? What will happen now? So if I try to call here E dot show, what will happen? What will be the output? Show E or show A?
E.
Show E. Okay. Why not show A? Why do you think it is show E?
Because of it's a subclass and then one is a superclass. So it's once you execute it, support the superclass. I mean,
like once we execute, yeah, go on. I'm listening, Asha.
it's a parent superclass. This one is the site. So when we execute, it supports the first superclass because of the this one is a subclass. So it executes first the superclass and after that is the subclass. That's how is the overriding goes.
If you see here, your class A has a show method, and by
It's the
default,
same
like I
name.
said, when your subclass inherits class A, the show method will be available here anyways, right? But even class E also has its own show method. So that means you have a same method with the same name, but in a different places, one in superclass and one in subclass. So in that case, basically what happens is your subclass method overrides the superclass method. It will override it. So whenever you try to call e.show, it will always print show.e. Okay. This is called method overriding. Let me just execute this program and then show E. When you call e.show C, it was giving compilation error because show C is of type is not present in A. Okay, but this is a compile time error. If you see here, this is a compile time here error. Okay, but this one okay, let me just do one thing. Now let me just remove the, yeah, remove show. This will not cause any compilation error or runtime error. Okay, I'm just commenting that because if you see here, right, the reference is of type A, but the object is of type E. Show, even though it's part of A, it is still available at class A. That's why there is no compilation error. But if you see show C, there is a compilation error because your object type A doesn't have any. Guys, just give me a moment, guys. Sorry for the break. Just give me a moment. Yeah, I'm back. So yeah, if you see here, your show C method, it's part of your class E, but the reference of E belongs to class A. Okay, so by this you can understand that the vice versa is not true. Okay, just because your subclass is extending your superclass, everything in your superclass can be part of your subclass, but not everything in your subclass will be part of your superclass. Just remember that. Okay, now that you have same methods in both these classes, right? Let me just comment this again. How does your Java compiler know, right? E.show, it should call this method instead of this method, right? How does your Java compiler know? Why it is calling this method instead of this method, right? Because of this new e. Okay, this is basically derived at the runtime, because your new e object gets created at a runtime, and at the runtime it resolves call to particular method, right? And that's why this is called, this particular method overriding. This is also called as, I gave you the another name when we were talking about polymorphism. What was it? Method overriding is also, it has another name, right? It gives something called a runtime polymorphism, because the call to show method, which particular show method to call, will be resolved at the runtime when your program is actually getting executed. Okay, understood, right? Now suppose in the same context, if you want to make a call to show a, what you will do? What you will do, guys? We'll just come here and we'll change it to this a. That's it. Okay. Now if I execute this, yeah, you can see here, right? So show a is getting called here. Now you can't change this to e. This will cause a compilation error, because you cannot assign a parent class object to a child class reference, but vice versa is true. Okay, you can assign a subclass object to a parent class reference because of the inheritance, because everything in your parent class is part of your child class, right? So understood, guys? Like if you have a same method in class A and class your superclass and your subclass will override the behavior of the method that is present in your superclass, and this is called overriding. So whenever we have a scenario like this, right, we kind of use this annotation override. Okay, so which basically, looking at this, tells this, on top of this method I added one annotation @override. So we are talking about new concept now, annotations. I'll tell you what this is at a later point, but just remember, if this annotation is basically looking, if you don't have class A in first place, right? Suppose you don't have access to class A, for example, right? So but looking at this, one can tell that we are overriding show method. That means there is a show method in class A also. It has some behavior, and our subclass child class is basically overriding that behavior, right? So we can so whenever you have overriding in place, we can use this annotation on top of our method. In addition to that, it will basically tell a compiler a specific set of instructions that particular override annotation will give you. Okay, so like in Java we have annotations like this. Okay, @override is one annotation. We'll talk about more at later point, right? So just remember, for now, annotation is something that gives your compiler some specific information about that particular method or class, on top of what you basically use this annotation. You have some class level annotation also, where you can annotate it at a class level, but we'll discuss that at a later point, like I said, right? But on the method, you, in case of inheritance, when you are overriding some method which is part of your super class in your base class, then we can put this @override annotation, right? Any queries here? Any queries here, guys? Is the concept clear? The method overriding and how does runtime polymorphism is working? Okay, look at this. The reference is of type A, but the object is of type E. Okay. Clear, right? But when you put this E, you can call the all other methods also. _C, _C, like this. Now when I execute this, you have print C, print A, and then show E. Okay, you make this type A. You will have compilers here because your class A doesn't contain C and show C methods. So your reference will take more effect rather than the object you are assigning. Okay. Any questions here, guys? So we basically spoke about runtime polymorphism now, right? And coming to the types of inheritance that we have, the next type of inheritance is multi-level inheritance. Like till now we were speaking about class B and class A inheritance, right? Now let's implement multi-level inheritance. Can someone tell me how can we implement multi-level inheritance? Your class A is extending class E. Now let's assume and I have another class. Okay. Let's call it as class B. Now your class D will for this should be the hierarchy. Class A, we have class E here. Now we have to create class D to form this multi-level inheritance. So which class should we extend here? Class A or class E? Which class will be we should extend here, guys?
Class E.
Okay.
Just look at it here. You have class A, here we have class E. Now we are trying to class D. Which class we should extend? E or A?
E. Oh.
All right, we will extend class E. Okay. Now if you see here, we created a relationship like this. Class A, class E, and class D, like this. Okay, this is your A class. This is your E class, and this is your D class. Okay, so we created this relationship. Okay, and just the same thing here. Okay, nothing much. And I think I'm not writing any code here. I think you must understood by this moment. And next you have hierarchical inheritance. Suppose I want to create hierarchical inheritance. Which class should I extend here? Look at the diagram. Class B and C.
Class A.
Yeah, so I need to extend class A. Now my D class will be here, right? And it's going to extend this class. This won't be there. Okay. This is this sort of inheritance, hierarchical inheritance. Okay. Now coming to hybrid and multiple. Okay. Let's talk about this. Let's talk about multiple inheritance. Okay. For multiple inheritance, we'll take another class. Okay. Because it should inherit two classes, right? Let's take. I'm just creating another class here. Class C. Okay. So here I'm trying to extend I think let's leave this here. So to create this multiple inheritance, okay, so that means one class is inheriting two classes at the same time. Okay, so our classes should extend what all classes? Let's assume those two classes are E and D. So
E
your,
and D.
so your class you should extend E comma D, right? But here is the catch. In Java, multiple inheritance is not possible. Okay. So that means your hybrid inheritance, both, if you see both are same, but it just had another level like this. So both these type of inheritances are not possible in Java. Okay. And remember this, in Java at any time you can extend only one class. Okay. So if you try to extend two classes, it is going to give you a compile time error. Okay. You cannot extend more than one class in Java. Remember, this is a strict rule. If you see, you can extend only one class. You cannot extend two classes like this. As at the same time, if you take multiple inheritance, there is another problem also. If you have a show method here, okay, and in class from class A you want to call show method. Now there is an ambiguity, right? Which show method will be calling, class A or class B, right? Because of these ambiguities, this is also called as diamond problem. Okay, because of these ambiguities, multiple inheritance and hybrid inheritance are not encouraged in Java. Okay, we can achieve them in using interfaces, which we will discuss now, but in general we will stick to single, multi-level and hierarchical type of inheritance. Multiple and hybrid we better avoid it. So you can think of it as a best practice. We are discussing these because these are quite possible here, and at the same time other languages support it, like C language, but not Java. Okay, guys, just give me another moment. I'll be back. Just 2 minutes. Sorry for this. Just 2 minutes. In the meantime, can you guys let me know the solution of recursion? If anyone have it, just please paste it in the chat, please. Yeah, I'm back, guys. Sorry to put you guys on hold. Okay. I think we have a solution from Varsha. Static in fact files. Yeah. Yes. Yes, Varsha, I think your program is correct. Okay. Guys, if anyone hasn't done it, look at the chart and take the solution of recursion. Okay. So if you see here, we are calling to calculate 5 factorial, we are calling the fact method, and this fact method, if you see inside, it is calling the fact method again, right? So this is the recursion, and this is most efficient, right? Okay. Now, any questions on the inheritance concepts? What have we just discussed now? Any queries here, or else I'll move on to the next concept, abstract classes and interfaces. Any questions here, guys? Any questions on interfaces, abstract classes? Hello? Hello? Am I audible, guys?
Yeah, yes, you're audible.
Yes, yes.
Any questions on inheritance?
No question. I'm good for myself.
Just remember, we can only use single or multiple or hierarchical. Okay. So multiple and hybrid inheritance, because of the ambiguity which I just said, right? Suppose just take the same scenario in Java. By default, you can extend only one class, right? And they introduced that because just to avoid the diamond problem. Diamond problem in the sense you have a same method in your two super classes. Your class A and class B is having same method, like show method, and now if your class C has to call the show method, which show method it will call, class A or class B? Which show method it will override, class A or class B? There is a confusion there, right? So that's why in Java they restricted the inheritance to at max one class. You can extend at any moment one class. So that's why your multiple and hybrid inheritances are not possible. Okay, so that's all with respect to inheritance, which basically imparts easier relationship. Okay, having said that, we also talked about method overloading and runtime polymorphism. Now we'll talk about abstract classes. Okay, so what are abstract classes? I'll just come here. Okay, I will. Now if you see, I'll just close this also. Okay, here if you see, my class E is basically extending my class A, right? And having said that, so that means in what context we use inheritance? Yesterday we spoke, right, to impart reusability into our code, right? And there is another important aspect why we use inheritance, that is to enforce some standards or enforce some mandatory implementations, right? Like say for example, let us just look at some some rather a generic example of inheritance, right? Like say for example, let us take our superclasses. You have one superclass. Okay, let's call this as animal. Okay, and okay, I think yeah. Now you have another child class of this animal. Let's call it as a dog class. Okay, this is basically a dog class. right? And now every dog basically has some, say for example, like say for example, let's call it as, I think you have different types of animals, right? Like say for example, you have different types of animals like mammals, okay, reptiles and all, right? Let's say you have mammals, reptiles and all, right? What is the basic difference between both of them, mammals and reptiles? Just a general knowledge question, guys. Nothing much. What is the basic difference between mammals and reptiles? I'm just trying to give you a real-time analogy so that you would think when you need to implement inheritance, right? Or or for that matter, talking about the next concepts of interfaces and abstract classes.
Mammal is the hot, warm-blooded, and then reptile is a cold-blooded, which is like
Sorry?
mammal carry baby, and then the one is not, and then each one is a cold warm-blooded, another one is a warm-blooded.
Okay. So if we take some examples, right? Let's take like one key difference. If we talk about, right, mammals will directly give birth to their babies, whereas reptiles will lay eggs, right? That's one key difference in terms of how they reproduce, right? Like mammals will directly give birth to a live, whereas reptile, they will put eggs, and that eggs will kind of eventually hatch into a baby, right? A baby, whatever it is, right? So that means every animal has some sort of like say for example, you have a reproduction capability, right? Every animal will have its own reproduction capability. Okay? Suppose you have reproduce method here. Okay, there is a method in our animal class. Okay, and let's take another one. Your dog is one, and I'll take another class here. Okay. And let's take another animal. Name some animal, guys. Any mammal, any reptile. Let's take lizard. Okay. Now, if you see, this is also belongs to your animal class. Okay. It is a reptile type, whereas your mammal is a and dog is a mammal type, right? So you guys understand this relationship so far, right? Is it clear? I'm just trying to model something in the real world into our object-oriented Java. Is it clear? You have an animal class, and which is basically a super class. Okay, this is our super class, and this is a child class. A dog is a child of your animal class. So that means we can say that your class dog extends animal, and at the same time your class lizard extends animal, right? Yes or no? Here this is the assumption that we are assumption I put forward before we dig into the further concepts. Is it clear?
Yes.
Okay. Now we discussed that mammals have a different capability on how they reproduce, and reptiles we talked about how they will reproduce. So that means your mammals and reptiles, they have their own different approaches to reproduce, right? They don't reproduce in a similar way, right? So if we talk about this particular scenario, that means my animal my animal class cannot define a generic functionality for both my mammals and reptiles. Can it? No, right? Your dog class will have its own definition for that method, its own implementation, and at the same time your lizard class will have its own implementation for that reproduce class. Yes or no? Your animal class cannot have a generic implementation for both of them, right?
Yes.
But now this is an important one. But at the same time, your animal class need to ensure that your mammal class dog and your reptile class lizard should have some sort of implementation for your reproduce class, their own implementation. It should reinforce it. How can it reinforce? You guys understood, right? This is the problem I gave you now. So far we had some assumption, and now the problem is your animal class cannot define the reproduce behavior because your mammals have a different approach, your lizards have a different approach, right? So that reproduce behavior has to be defined between those respective classes. That means within dog class and lizard class, right? They should have their own behavior like this. Okay, like say here it is live birth. Okay, whereas here it is lay eggs. Okay, they both have different approaches, right? But your animal class should enforce or somehow ensure that the both dog class and lizard class have overridden that reproduce method or given some implementation to it. How should we ensure it? How can we ensure it? Let's assume this is your okay D, and okay, I'll just close this E class. Okay, your this is your animal class. So let's assume D is your dog class. Okay, and I'll create another class, lizard class L. Okay, now this class also extends a animal class, right? And here you have reproduce method. Okay, so now I said they will define their own behavior, right? The same idea I'm just putting into the programming here. Okay, right? See here, my class A method, okay, my superclass method has this reproduce method, and my child classes defined their own implementation for them. Okay, yes or no? This is what we are looking at here. Right? There's nothing much. Is it clear what we just did right now? But my question comes now here. Your class A didn't have any implementation for reproduce method, but it should ensure your subclasses will override it. How can we do that? Override in the sense, as an animal, I don't know what should I do for that particular method, right? But my child classes should define some behavior for it, their own behavior for it. So how can I ensure it? Okay. Here, if I don't override is also fine. It's not a problem. Okay. This is an error scenario for me, but I don't have any implementation for reproduce method. Superclass will say subclasses, you should define your own implementation for your reproduce methods, right? But unfortunately, we cannot. By looking at here, there are no errors anywhere, right? In any of the classes, we are not seeing any errors. So that means can't our superclass cannot enforce our child classes to mandatorily override a particular method? Can't we enforce it? That's the question. But looking at this, it doesn't look like we can't enforce. Yes? Yes or no? Either they choose to override it or they may not. Isn't it the case? At least now. So are you guys understanding the problem statement here? Asha, Varsha, any confusion here? Is the problem statement clear, guys? As a superclass, I want to enforce my child classes to mandatorily override certain methods.
Zero. That's it, you're still in zero.
Understood? Guys, acknowledge me so that I'll know you guys are understanding. Else I'll repeat the same thing again.
So the two of the classes, subclasses, L and B, they have different methods, lay eggs and birth. So you want to, so in a super class, you can have a method, both method, and only show a method that is required for a particular subclass.
Is this Varsha? Okay.
Yes.
Yeah, that's it.
So we should have two methods in our superclass, is it?
Right. I don't know, like I'm just guessing, like.
Okay, yeah, got your point. Thanks for that. Okay. But you understood the problem here, right?
Yes. So they have two different.
I am not asking you guys solution here. I just want you guys to be clear of the problem statement here, because if you don't understand this, you will not understand anything about interfaces or abstract classes. Okay, that's why I'm so particular here. I want you guys to be clear about the problem statement, right? You have your class A, and your class A should restrict. See, Asha, if I have to put both methods in class A, then what's the point of my subclasses? Why do I need these classes in first place? You got my point? End of the day, you have subclasses, and your subclasses should override your behavior in class A. Okay? That is something we definitely need. But how can my class A will force my class D and class L to extend that behavior? Understood the problem, guys? If you guys understood the problem, then I'll talk about the solution part. Okay. Now, if you see here, okay, you have different implementations, right? Now my class A should, here I am not forcing my class, doc class and lizard class to provide implementation for this reproduce method, because here I didn't give an implementation, it's an empty method. If I want to enforce this, right, I'll just remove this quotes and I'll just simply put colon here. That means I am not giving any implementation for that reproduction method in my class A, and whatever. So if there is no implementation, we will put method this way, but still this is giving compiler error. Having this is putting this, removing this implementation is not just enough. At the same time, we should tell Java that for this particular method, I am not giving any implementation. I am not defining any body for it. Okay, I will let my child classes do that. to ensure that we use this keyword abstract. Okay. ABS. We use this abstract keyword. Okay. So the moment I do this, when I name my method as an abstract, I should also make my class as an abstract. Okay. Now the errors are gone. Okay. So that means the moment I make this method as abstract, automatically I should also make my class as abstract. Okay. If a class contains one abstract method, then class should be abstract by default. Okay. So when I made this, now look at the compilation errors here. What it is saying? Read the error. Are you guys reading the error?
Yeah.
What it is saying? Okay, if you guys read this error, here also we are getting the error. What is this? Just read this also. So basically, the moment you made it abstract, we are forcing our child classes to mandatorily override this method and provide it some implementation. Okay. Now I'll say add an implemented methods. Now, if you see this, your Java generated this automatically for you. Here, I'll put the code. Okay. I'll put now when I override this. Okay.
Your voice is breaking for me. I don't know. It's the same for everyone.
Is it the case, guys?
Yeah, me too. I can able to hear perfectly some of the words too.
Okay. Just let me know if it repeats again. Okay. Is it clear now, Asha and Vasha, or is it still like that?
Yeah, I understand that.
Okay. Okay, fine. So now if you see here, right, the moment I made it abstract, I got a compilation error like this because my child class is not overriding this reproduce method. But if my superclass, if it has to force my child class, I'll simply make my method abstract, then I'll get the compilation error and then I'll override it, and I will definitely provide by default, I am bound to give some implementation for that method reproduce. Okay. So, and here also to remove the compilation error, I'll just override that method. Okay. I'll give my own implementation again here. Right. Now you can see that. Now you can see everything is fine, right? Now see, now using this abstract keyword, we can come to a conclusion that we can create methods. We can basically create a methods which doesn't have any implementation, right? The moment you make any method in your class abstract, this abstract keyword is applicable only for methods. It's not applicable for variables, guys. Remember, I can't put here abstract int. Okay, abstract is nothing but it's saying it's just a declaration. It's not giving it any meaning. Okay, it's just a declaration. But the moment you make any method abstract, you have to make your class also abstract. The moment you say your class is abstract, what is the meaning that it sends is, it says that my class has some methods which doesn't have any implementation. They are abstract. That means they are just declarations, right? And whoever is extending me should definitely provide this implementation for it. Okay. Understood, right? Now, for example, here my class L is extending class A, right? So that's why I definitely have to provide this implementation for the reproduce. If I don't want to do this, okay, I'm just commenting again. But still I want to avoid this error. How can I do that? Any idea? I don't want to implement reproduce method, but I want to avoid this error. How can I avoid it? I'll make this class also abstract. I'll make class L also abstract. See, now the error is gone. But that means whenever you're extending an abstract class, you should be implementing it. If you're not implementing it, then you should also become abstract class automatically, right? Understood, right? Abstract class is nothing but it has some unfinished thing to do. You can assume it that way. If you look at the class A, the reproduce, it's unfinished thing, right? So keeping this in mind, you cannot create objects for abstract class. Okay, you see here, I cannot create an object of class A. This is not possible. Okay, cannot instantiate type A. Why can't we create an object for class A? Because it is an abstract class. It is unfinished method. Okay, just remember this. This is a really important thing. Okay, we cannot create any objects for abstract classes, but you can create object. So forward this problem, you will have a D here. We'll put D.
So, what is the use if we already have an inheritance? I don't see any use for abstract class if there is an inheritance.
It is there now. Using abstract class, you are enforcing your child classes to implement something, right? Else, if it is not abstract class, it's not mandatory for your child class to define something, right? Basically, using abstract classes, we are enforcing some contract. Okay, you have to do this for sure. I'm mandatorily enforcing it upon my child classes. Can we do that with inheritance? It's not possible, right? In the plain inheritance, we can't do. Only when your methods and classes abstract in case of inheritance, then you are enforcing your child class to mandatorily override the reproduce. So that's why I have been iterating the problem statement earlier. Okay. Understood, right?
Yes.
Since your abstract class is unfinished, you cannot create objects for it. Okay. This is illegal. Right, you're creating A because your class A is not. Okay, I'll just close this L and D and I'll open this class E. Okay, now if you see here, I'll just bring it sideways. Yeah, now if you see here, my class is extending class A, right? This is not possible. I cannot create object of class A because it is an abstract class because it has unfinished thing. But my class C, I can create an object because everything is completed here. Does it have any unfinished things? No. But still my class C is throwing an error because when I'm extending my abstract class A, I have an abstract method which doesn't have any implementation. So my class E has to definitely implement it, add unimplemented methods. The moment I override this reproduce method, now this error is also gone, right? Now if you want to call this method, then you can e.reproduce. Okay, so that is the whole concept of abstract classes. Okay, now if you remember, what are the you have one particular object. Can you name me the object-oriented principles again, guys?
Abstraction, polymorphism, inheritance.
Yeah, abstraction, right? And how we are achieving abstraction? Abstraction here is achieved nothing but using abstract classes and interfaces. Till now we discussed with abstract classes. Okay, abstract class is the way we can achieve abstraction in Java. Okay, what is abstraction? If someone remember, what is abstraction?
It hides the complexity of the application and only shows the relevant attributes.
Right. So if you see here, your parent class, like class A, which is basically an abstract, right? It is hiding the implementation to reproduce. Okay. we are dependent on the abstraction. So if you see, we will just make use of this abstraction, but our child classes will provide actual information. Okay, how your child class implemented that reproduce method doesn't matter to you. Okay, you are not overwhelmed by the implementation of that reproduce class by your child classes or any concrete classes. Okay, so whatever class we implement that reproduce, it is called a concrete class. So that means it's completely full. Okay, so all non-abstract classes, you can think of it as a concrete class. Okay, something extending another class and giving implementation for that abstract methods is nothing but a concrete class. So your E here is concrete class. Okay, so we are not worried about underlying complexity or nuances of how your class is implementing that reproduce. Without that, we can just simply make use of the reproduce method using the abstraction. Abstraction is like it will just it is not exposing. If you look at, suppose your class E is not accessible to you. Okay, it can be private. Okay, all this can be private. Your class is not at all accessible to you. But just, if you see now class A, you just made use of class A and you are calling these methods, right? Now if you see here, if you see this, the key thing here is you are not, your abstract class is basically hiding the implementation of reproduce class, which is implemented in which class? Class E. Your class E provided implementation for reproduce class, but when you look at your abstract class, you don't have any view of what is the underlying implementation, right? Yes or no? So you're basically hiding the complexity of the reproduce method, which is being implemented by your concrete class, right? So you are hiding all the unnecessary details. I see you are only interested in using that particular method. You are not bothered about what is actually written in that method, right? So this is called abstraction, which is the important object-oriented principle. Okay, so like I was saying, you can achieve abstraction using both abstract class and interfaces, but we just spoke about abstract class alone today. Okay, so tomorrow we are going to talk about interfaces. Any queries, guys? Here, we'll stop for today. I'll take any queries. If you guys have any queries, I'll just take them for some time.